Lecture 10 is the reservoir or pond. Small size reservoir we call pond or farm pond. Okay, the physical characteristic of the pond or reservoir. This curve is show the three components. The first is the water surface area, storage capacity, elevation of the Pumipon Dam. Okay, so you have see that on horizontal scale is the storage capacity in unit is a million cubic meter. On the top is the surface area, square meter. Okay, the left and right side is elevation. So we can read from this that, for example, if the elevation is 200 meter, so we can find the capacity curve from capacity curve to read from the curve. So it's about 2,400. So storage, water storage is about 2,400 million cubic meter. Okay, and if you draw to another side, and read from this, it means the surface area is about 80 square meter. The surface area of the reservoir. Okay, so that's for the Pumipon Dam. The maximum storage is about this number, 12,000 million cubic meter. The maximum capacity of the Pumipon Dam. Okay, another picture show the profile of the dam. Okay, before the dam is built, this is a no level of no dam. Sorry. It's the initial water level. When the dam is built, the water level is up to this level. We call the normal level. Level, and this is for the maximum level, and this minimum level. And this part is their storage. This means we can't take the water from this part. Just keep the sediment at the bottom of the reservoir, and we can get the flow from this. Okay, passing through the dam. Okay. In this curve, to operate the dam, release the water from the dam, the operator use this curve we call the rule curve of Pumipon Dam. Okay, so just control the water level between the reservoir elevation and the month of the just control. It depends on the wet year or dry year. You see the minimum level is about this, and for the low LRFC is lower rule curve. Okay. And this is upper rule curve. This can be like on the dry year, and this can be for the wet year. You can increase the water level in wet year. The main topic of this lecture is how can we calculate the reservoir storage. Okay, we have two methods. The first method we call the mass curve method. The mass curve is based on this equation. We do integration or accumulate volume of water it can be the monthly volume to and do accumulation and plot the curve between accumulation volume with the time. Okay, for example, this is plot between the accumulate flow in unit of the million cubic meter with the month. Okay. Okay, and this one. Okay, and we can say that this is a called a demand supply curve. So we can draw another one we call demand curve. So we start to build the slope first. So this one is demand slope. Okay, demand slope. And next we compare between demand slope and this is supply slope. Okay. From point C, we draw the curve parallel to the demand curve. Okay. From point C to point D, and we draw another line. Okay, so this parallel line, the gap between this line, we can measure the is it S1. Okay, S1, and we do again above. And we draw parallel line from C prime to B. Okay. From C prime to D prime parallel to the demand. Another one point, but okay. So we can measure the S2. Okay. After we measure the scale of S1 and S2, we can come to conclusion that if S2 is greater than S1, we say that we choose S2 is a reservoir capacity. Okay, so it means it's a reservoir size or reservoir capacity for S2. Okay, that is a short way how to use the mass curve to estimate the storage. Estimate the storage capacity of the reservoir. And this figure show the similar way. Okay, we have to correct the scale first. This scale should be 1,000 million cubic meter. Okay, so we start from demand. Demand is, we know the demand is about 92 million per year. Okay, so we have to compare with the scale, and we measure this length. We just directly measure from the graph, and we measure, for example, we got 2.55 centimeter. Okay, so 2.55 centimeter is equivalent to 250 million. Okay, this one is 250 million. Equal to so we can make proportion that if 92.51 is equal to 0.94 centimeter. So we just draw we build a slope. This length is about 2.94 centimeter, and this one is 1 year. Okay, and from this we can, from point A, we can draw the parallel line. Okay, and this one because like S1, and we do the same as point H. It means from beyond point H, it means the demand, the supply curve is slope, supply slope is less than demand slope. Or we can do another way. We can draw another just similar to the previous one. It's a parallel line. Okay, and we measure S2. Okay, and we measure from S2. What is the length of this? Just ruler to measure is about 0.7 centimeter. So we can do the proportion. Because about 69 10 power 6. So that is a storage. This was storage. Okay, we choose the reservoir storage about 69 million cubic meter.